Okay, let's talk about sets. So basically, a set is a list of objects. So we often give sets names. So I'm going to, for example, give this set A a name, and we put it in what's called braces. If you can't draw a brace, just draw a squiggly line. If you're using your keyboard, then it's above these brackets. So you have to do shift these brackets and you would get the braces if you are typing. So it's just a list of things. So I could put in here A, B, 2, 3, 4. And I could make another set, B, and I could put in it B, C, 1, 2. That's enough. Put that in it. And those would be our sets. Okay, then we have a set that we call the universe. The universe has everything we're talking about in it. So in this case, it might be A, B, C, D, E, and it might be the numbers 1, 2, 3, 4, 5. That's everything. Now we can demonstrate these things by what we call a Venn diagram. So usually we write the universe as some kind of a rectangle, and we write the sets within it as some sort of circle. So everything that we have in this set right here, this little circled set, so let's say we call this set P, then everything out here would be stuff. There's not a mathematical word. Stuff in U, but not in P. So that would be all the stuff in U, not in P. We call that P complement. So you can write it with a line over it, or you could write it with a little C up here. But basically it just means the stuff not in P. So all the stuff in P, all the stuff not in P. All right, let's look at if we have two sets. And let me copy this here. Get all of it. Here we go. Put it that way, copy. And I want to put it down here so we can still see it. While we look at this one. So if we call this whole thing U as the universe, we call this A, and we call this B, this in here is called the intersection. So we call that intersection. So that's stuff that's in A and B. Stuff that's in A and in B. So when we look up here, what stuff is in A and B? I see B is in set A, and I see B is in set B. So B is one of the things that's in here. I see 2 is in set A, and I see 2 is in set B. So it's in both. Right? I also see in set A, 3, and 4 that are not in set B. And over here in set B, I see C and 1 that are not in set A. So now by looking at this, I can see that B and 2 are in the intersection where they overlap. this whole thing over here, all of this, including the B and the 2, all of that's set A. So all of that stuff's in set A. Notice all of this stuff is in set B. Okay, now when I look down here to the universe, what is the stuff that's not in A or B? Well, A was in set A, B was in both of them, C was in B, but I don't see D or E. So D or E are down here in the universe, but they're not in set A or B. 1 I see is in set B, 2 I see is in both of them, 3 is in A, 4 is in A, but I don't see 5. So 5 is down here in the universe. So this is a way to look at the Venn diagram and see what's overlapping and what's in both of them. Now we also have another thing that we call union. A union B, and it looks kind of like a U for union. And remember, we use or, that looks kind of like a V, and we use and, that kind of look like an upside down one, or A. The symbols are similar together on purpose. So this stuff that's in either, stuff in either A or in B, or both. We're using inclusive, so we could list the stuff that's in both. A, B, C, D and E are not in them. 1, 2, 3, 4. So everything in this list is either in A or in B or in both. So that is called the union. If I wanted to color these in, I could color this middle part in. That's coloring the intersection. I could color that part, this part, and that part, all of it, and that would be the union. So the union is coloring all 3 of those places. Now I could get all fancy and talk about the complements, what's not in there, and so forth, but I'm going to save that for a different class. Now, sometimes we can have a set where set's right inside of a set. Whoops, let's not use black, yellow. Let's use black. So I can have a set, a universe. And there's a set. And there could be another set inside of it. So I could have the universe, I could have set A and set B inside of it. So what's an example of something like that? The universe could be let's see, the universe could be students, and A could be math students. And what's something that math students all have in common? Math students could be Math 154 students. So that's telling me that all students out here, so there could be English students out here, psychology students, history students, and they might be in here too. Those might be overlapping. But math students are here, non-math students are outside of that. Math 154 students are math students. Calculus students would be over here. Now they wouldn't overlap unless they're also taking Math 154. which seems very unlikely that you would have a calculus student and a math 154 student at the same time. So those would be separate. So let's put those over here. Whoops, I didn't mean to make it purple. Make it black. Little group C over here, and we're making C smaller. C is calculus students. And notice there's no overlap because we don't have math 154 students and calculus students at the same time. Now I'm saying it never happened, but it really shouldn't. So those don't overlap. So one could be inside of another or not. So you actually have an activity this week that's going to be based on these kind of things. So how are you going to do your activity? You're going to come up with two sets, whatever sets you want. And are they going to overlap? Well, we don't know yet until you ask some students. So your activity, you're going to have to wait until you get the answers to your discussion board. So in your discussion board, ask two questions. You can ask whatever you want, except don't copy me. You want to ask yes or no questions. So the person can say yes or no, they're in the group or they're not. So do you wear glasses? Could be an example. And every student's going to say yes or no. Do you like sushi? And every student is going to say yes or no. So let's make up some students. So perhaps Carl says yes, he wears glasses, and no, he doesn't like sushi. So here's A and here's B. Where does Carl go? He does wear glasses, but he doesn't like sushi, so he's over here. What about Tom? Tom says yes, he wears glasses, and yes, he likes sushi. So where is Tom going to be? He's going to be here in the middle. What about Marla? Marla says no, she doesn't wear glasses, and no, she doesn't like sushi. So Marla's going to be out here. And then let's say you have Cindy. Cindy says no, she doesn't wear glasses, but yes, she does like sushi. So she's going to be in here. And then if you want, you can put yourself in there. So since I'm doing this one, I'll put me. Catherine, yes, I do wear glasses. And no, I don't care for sushi. So where am I going to go? I go in here with the glasses, but not overlapping with the sushi people. So that's how you will end up with your Venn diagram at the end. Your universe is the whole 154 class, and your answers to your questions, which are yes or no, we'll put them in the set. My set A is glasses wearers, right? So my set A is glasses wearers. And my set B is sushi lovers. All right, so that's how that one's going to work.